So this is part 2 of the Iron Man flying robot, which is using 4 EDFs, 2 on its back and 1 on each arm, to direct a jet of air to fly, just like Iron Man, or just like the guys from Gravity CO. So those are the guys with the gas turbines on their arms and backs who can fly around in a jet suit. So this is basically the scale model version, and I've got servos that move the arms and this crazy controller that I built last time with 4 axes on each stick, and we're going to try and control the thrust a little bit manually and also direct the jets of air by moving the robot's arms and see if we can fly. And to start with, I'm going to do all of that manually, and if it goes badly, we'll put an inertial measurement unit and try and put a flight controller in. But for now, it's a full manual control. Just a quick ad for my Patreon campaign. Don't forget you can support me on Patreon and you can get exclusive rewards like a live stream with me, all my videos early, and sneak peeks and pictures of the upcoming projects. And if you don't like Patreon, I have YouTube channel membership, so just click on that join button below. Also, don't forget my Teespring store where you can get t-shirts of Open Dog and Robot X, and also bags, socks, and lots of other merchandise. Check out the last video for more explanation. But basically I've got 4 EDFs, and these I've got 2 pairs of counter-rotating EDFs. So this one turns this way, and this one will turn this way, and then this one will turn this way, and this one will turn this way. So hopefully the whole thing won't spin, because we've got those 2 sets of EDFs rotating in opposite directions. And check out the last video to find out how I pieced those together from multiple EDFs from multiple manufacturers. And the motors in here are the Dr. Mad thrust motors from Hobby King, but they draw 80 amps peak each. So today we've got to put the controllers in, the electronic speed controllers, and also sort out the power distribution. Last time we got the servos moving, so its arms move all around, and we've got our controller, of course, that controls those arm axes. So we've got to attach the ESCs. I've got the Hobby King ones. These came out of the Rocket Challenge with Ivan Miranda, so I need to alter the cables and things on those. We've got 2 Turning G Plush ESCs as well, and all of these are 90 to 100 amps, 1 for each EDF. The battery is a high C rating, so we can draw enough current from it. It's still a bit underrated, but we'll see how it goes. So somehow we need to attach all of the power ins to the power out of the battery with some sort of power distribution. Alright, so I've put eyelets on all my ESCs, these 8mm eyelets, and we're going to use 2 bits of 8mm studding in this 3D printed thing to attach these 2 as well as the battery, and stick that there on the 2020. So then we can do the power distribution, and that should be enough to handle the current. So there's my power distribution fitted, and I've got the battery, which is in the front, this yellow thing under his jumper, with the cable there and the connector there to connect them together, and that powers all of the ESCs. So I hope these cables aren't restricting the flow coming out of the back ones. I might have to pin those back, but I think that looks all right. So they've all got power. Now we need to wire in the signal to the throttle, so to these cables and these cables, which are to actually trigger the EDFs and control the speed. And those get wired into the Arduino, which is hanging around here so far, with the radio receiver, and that eventually will fit in his helmet. So I've wired in my EDFs, and I've got them in 3 groups, obviously 1 on each arm with the 2 triggers on the remote, and the ones on the back both work together. So yes, we're going to test it on this tether system, which is 2 bungee cords, and see if we can get the bungee cords to go slack, and if I can control it at all before we smash it to pieces. And what I've done with the joysticks is now when I push my arms forward, he puts his arms forward, and when I put my arms out, he puts his arms out, and he puts his arms in. So that's hopefully going to be more natural to try and control it, but we'll see what happens. And this is the first time I've actually tested it at all, really, apart from checking the EDF's power up. Whoops. So I noticed I didn't have as much power on this right-hand EDF as I did on the left-hand one, and then there was a terrible smell of burning, and now the motor's actually too hot to touch, and the EDF is completely seized up. So I'm not sure what's happened there. Yep, so this is one of the original EDFs that I crashed in Spain, so I don't know what's happened there exactly, but it would appear the plastic, the motor has slipped back basically, the plastic's melted itself together, then the motor's burnt out, and if we look in the bottom very carefully, probably can't see on video, but some of the coils inside are all blackened and expanded, so the motor's seized, and then it's all burnt out. Right. Well, I think we've got glue. So it's sometime later, and the original EDFs are still on back order at Hobby King, so I can't get any more at the moment, and the motors and actually the shroud, so I've actually replaced them with Dr. Mad Thrust branded metal EDFs, and these are aluminium, And they seem to be a lot more well balanced actually, but I can't get counter-rotating ones. So I've still got counter-rotating on the back, but these both rotate in the same direction, so I'm not sure what impact that's going to have. If it works well, I'll probably replace them all, just because these things are pretty nasty. And these all come assembled in one piece and they seem pretty solid. So that made a funny sound to start with and a bit of a funny smell, but actually on closer inspection we can see one of these other plastic EDFs. Now you can see the middle's not rotating on centre, it's actually come out and all gone crooked and it was vibrating and being horrible. So I think I'm just going to have to replace these two as well. Right, we've gone all metal all the way round, so I don't have counter rotating anymore though because I can't get them, so they all go the same way. So I'm not sure what's going to happen, but we should be able to put one hand forward to kind of compensate for twisting, so maybe it'll be okay. Well, we know it's got enough power to go up, so then no problem with the amount of power I've got on these 4 EDFs, so that's pretty good. It's just quite hard to control, so I think what I need is my 2-string tether that I used last time to try and hold it to stop it twisting, at least till I get the hang of it. Right, I've got rid of the stretchy bungee, so now we've just got some paracord, so it doesn't bounce around so much. So we seem to have quite a lot of problems with it twisting due to the fact my EDFs don't counter-rotate anymore, so I've now realigned the arm ones. So this one points slightly forwards, and this one points slightly backwards, and hopefully that's going to compensate for the twist. At the moment the backs are still straight, but if we have to skew that as well one way or the other, then that's totally possible. So something very exciting happened. I got a contact from the Gravity.co guys, the actual jet suit guys who fly around with gas turbines on their backs and on their arms. And they've been helping me out with how to make this work properly. So they said that basically they've got 3 equal thrust vectors, which means that the big jet on their back is equal to each arm. So they've got 3 equal power things basically that lift them up, and that's how it works. And so what they do is ramp up to full power, and then they just move them in, and that's how they take off without increasing power. So what I've got though is a problem where I tend to fly backwards when the arms are out, as you'd expect, even though I've got 2 of these jets on my back and 1 on each arm. So that probably means my angles are wrong. So what we're actually going to do is move these jets outwards so they push back more to compensate for when the arms are out, and then we're going to try it that way. They also mentioned that my legs are a little bit light and they're not the same as a human centre of gravity, which should be centred just above the hips, although we do have that battery in there. Although I'm not sure about that because of the pendulum rocket fallacy, which says that if you've got sort of mass hanging below some thrust, it's not really any more stable than if the thrust is below the mass. So obviously we had this debate when we did the rocket challenge with Ivan Miranda, because he had his jets at the top and I had mine at the bottom. So we're going to make that modification and see if we can get any further. So I've made this piece of plastic which has got an angle on it, so that's going to fit in between the plate that's mounting these at the moment and the extrusion, and obviously we'll be able to print another one and change that angle if we have to try and get the angle of these correct. So that plate's fitted, so now that you can see those are sticking out a lot more, obviously we should ramp down the power on these, or just have one of them to match these. But we'll see how it goes. I think I want to fly forwards unless I put the arms right out. I'm not really sure how it's going to work because I can't bend my hips like they can to vector all of these at once, of course. So I'm going to leave it as it is for now and power these down as we go. Well, it physically hit me twice, so we've probably outgrown the test rig, I think, but it feels like it wants to go, and it feels like I can almost control the twist. Probably need to balance up the front and back a bit there, but that's just a code change. But I think we need a bigger place to test it, and I think we need some help from the professionals. That's right, we're here with Richard Browning of Gravity and his team, and we're going to try and see if he can fly this if I can't. So, a couple of quick things before we get started. So I've got on here, I did have 2 triggers, so that was the left and right balance, but that's not how you do it, right?
No, in our suit we've just got 1 trigger. We did the same thing at the beginning. We'd have a trigger in each arm to control each arm, which found you don't need it. You want all of the power consistent anyway, so we just went down to 1 trigger.
So then you just basically bring your arms in and you thrust vector. So if you have too much power on one side, you put your arm out.
You pull the throttle up to full power, and then you hold them all the way out, and then you do all of the vertical control just by bringing your arms down.
And your gas turbines, I guess they don't make counter-rotating gas turbines.
No, they all rotate the same way.
They all go the same way,
Yep.
so do mine now, so there we go. And you just control that. Do you actually feel the rotation, or do you...
No, the speed at which they spool up and spool down is so slow that you don't feel it at all.
Right, and you don't get any spin?
No.
Okay, good. Well, we're going to try out the mini Iron Man on their tether system, so let's see what happens.
If you just take in the slack to there, basically you can't fall over. What a handy robot training tether. That's enough, I think.
Yeah, awesome. So Richard has suggested putting the battery on the legs here to keep the mass low, although the pendulum rocket fallacy would say that it doesn't matter where the mass is, but we'll see how it goes. It's a bit more like a human weight distribution with heavier legs than just the thin, spindly, empty prints that I've got there. So we'll see how that goes, at least on the tether. My laptop resetting the serial port. Right, we're just going to give more power. The back's turned down because there's 2 thrusters, so I'm just going to turn it back up to max. We'll see what happens.
That fooled me because I instinctively went, I think, the right way, and it didn't do enough. So then after that, I just lost faith. I knew what I was doing.
Yeah, exactly. You very quickly forget which rotation direction is which.
It's like driving a digger. You have 2 joysticks, and after a while, you just forget entirely what they do. if somebody asked you, you wouldn't have any idea, but you can see the results of your action.
Yeah, and that's what we were just talking about, is having a POV camera on there. So like the FPV racing.
Oh my god, and a bucket.
Right, I'm here with Sam from Gravity. He's been doing some testing because he can probably fly better than I can. So what do you think?
Well, it's certainly hard to fly. The rotation is again counterintuitive. Technically, the way you're moving these is the same direction that you'd move while flying the suit, but while trying to look at something that is separate from you and not getting the kind of spatial response of the area around you moving opposite to how you're moving your arms, you can't get that feedback. And I've flown a lot of FPV mini quads, and having that first person view is what kind of gets you back into the zone of the thing itself. So I reckon
you had FPV goggles.
Yeah, FPV goggles, and maybe a camera on him. We were talking about having an HTC Vive with the outputs going straight into this. I think you need that first person view because trying to cope with the rotation with the few goes I've had has been really, really hard.
Yeah, okay.
But it's certainly being able to throttle up out here like we do on the actual suit and then vector in and bite into that thrust component that you have is the right way to be controlling it to make it mimic the suit.
So I was lucky enough that Richard let me have a go on the suit. I only had limited power, about 60% of the force needed to lift me, but that's enough to get a feel for it and work out what you need to do with your arms to balance up in all directions to try and control your position with the jet on your back as well. So this is just warming up all the gas turbines, which happens for about a minute, and that's so it doesn't shock the metal basically inside them, and they get nicely warmed up before we go to full throttle. And we do the same thing on the ramp down as well when you finish for about another minute to cool them down. Try and look ahead of me.
Yeah, that makes a big difference.
It was blowing you backwards to begin with because you had too much pointing forward.
Yeah, okay.
He was trying to describe if you just bring them round to your sides, then it'll blow you less back. But it's a lot to think about, isn't it?
Yeah.
Crazy hand. That's on what, 60% power?
Yeah, 60.
Okay.
60% from what you need in order to fly. So realistically, about probably 40% of their overall power.
Oh, right. Okay.
You don't really forget it.
Oh, sorry, man. Got it. Right, that was epic. Thanks again to Richard and the Gravity team for having me here today to test my little Iron Man and of course have a go on the suit.
It's been a pleasure having you here with the little Iron Man robot. That was superb. It does need a next stage, I think, so we can better employ our learning of how to fly in reality to that robot, but that was super fun and you did great for the first couple of goes.
All right, thanks.
Really, really good. So look forward to the next time. And if you want to see more on what we do in Gravity, if you look at the hashtag #TakeOnGravity on pretty much every social media channel, then you'll find loads of everything from the beginning where we spend most of the time falling over right through to any one of the 80 odd events we've done all over the world. So yeah, keep following us on there.
All right, that's all for now.